All right, guys, we're going to be looking at elimination when solving systems of linear equations. And in this video, what you're going to have to pay attention to is we are going to have to manipulate both equations. So the first thing we want to do is line up all of our like terms, which we have already. And the second thing we're going to do is find out which coefficients we can cancel by making them opposites of each other. So I'm going to start this problem by looking directly at the x's. I like the look at those x's. And what I'm going to ask myself is 5 and 3, although they can't cancel right now, I'm going to make them to where they are the same number. I know that 5 and 3 are both divisible, or I'm sorry, will both divide into the numbers 15. And because I'm going to pick 15, I need a negative 15. Okay, so that they will be able to cancel out. So I'm going to 15 and negative 15. In order to do this, I'm going to start with the first equation. I'm going to go ahead and multiply everything in the first equation by 3. And when I do that, I have to distribute that 3 in to both places. So 3 times 5 is 15x. 3 times 4 is 12y. And then I'm going to multiply by 3 in this case, which will give me negative 90. Now, the second thing, if you'll notice what I've done is I've gone ahead and gotten rid of the 15 because I've got a 15 that shows up right there. What I'm going to do now is I'm going to get that negative 15. And how do I do that? Well, what do I multiply 3 by to get negative 15? Negative 5. And I'm going to do that on both sides of the equation. So I'm going to distribute that negative 5, and that gives me negative 15x. That would be negative 5 times negative 9, which is positive 45. Y, and then negative 5 times negative 18, which is going to give me negative or positive 90. Okay, now that we've got that, hopefully you'll see why I picked 15. They both divide into 15, and I have a positive and negative 15 there. I can go ahead and do the elimination method simply by adding the two equations together. 15x minus 15x cancels. Give me 0, 12y plus 45y is going to be 57y equals to negative 90 plus 90 is 0. Okay, and then we divide by 57. At this point, what you should see is that y is going to be equal to 0 divided by 57, which is 0. Now remember, our answer is going to be an ordered pair. And so what we want to do is set up our ordered pair. Remember, it's x and y, and the y value is going to be 0. So now all I need to do is figure out what x is. Pretty much what I do is I just pick one of the equations, one of the original equations that I had, and I just plug in 0 for y. So I'm going to erase all this extra work up here so I can write down the equation correctly. And I'm going to say, all right, well, let's do 5 times x plus 4 times 0 equals to negative 30. Notice what I did was I used the first equation and I plugged the 0 in for y. Okay, and then now what we're going to do is we're just simply going to simplify from there and simplify and solve from there. So I'm going to have 5x plus 4 times 0 is 0 equals to negative 30. Which gives me 5x equals to negative 30. And then I could just divide by 5. X equals to negative 30 divided by 5, which is negative 6. I could plug that in. So our coordinate point should be negative 6, 0. Of course, we've shown our work algebraically. I'm going to want to do this graphically just to check my work. So I'm going to go off to Desmos and I'm going to plug both of those equations in. Does not matter the form, standard form or y-intercept form, doesn't make a difference. I'm going to turn on those equations. And what I'm going to do is I'm going to look for their intersection. Notice it is at negative 6, 0. That proves that all the algebra we just worked on is correct. All right, y'all have a great afternoon. Come on back anytime.